Hello, everyone, and welcome to our webinar, Using ANN for Vector Search at Speed and Scale. My name is Matt Brown. I'll be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars. We do 2 per week now, demoing data and AI use cases, new tools, and new technologies. I post about these upcoming webinars every week, so if these topics are interesting to you, feel free to connect with me on LinkedIn. I'd also love to hear your feedback on or ideas on topics that you'd like to see us do in future sessions. So speaking of future sessions, if you click to the next slide, you will see that on Wednesday of this week, we will be presenting inventory management using object and image detection. Come join us to learn how businesses are using AI to manage their inventory more accurately and to reduce their operational costs. If this sounds interesting to you, you can RSVP right now. There's the bit.ly on your slide there. There's a QR code that'll take you to the same place to RSVP and get your spot. I'll put that link in the chat in a minute. Back to today's topic, we would love for you to participate in the discussion throughout the session using the Zoom Q&A button at the bottom of your console. We have an internal mission to try to answer 100% of audience questions. That has gotten more and more difficult over time as we've gotten now thousands of registrants for each webinar, sometimes hundreds of questions, but we are up to the challenge. So ask away. We will answer every question, even if it means following up via email. Just make sure you include your name and email address when you ask the question. We won't be answering anonymous questions. We would also love for you to try out the technology that we're going to be showing today. In fact, anyone who tries it today will be entered for a chance to win the brand new AirPods Pro, the latest and greatest that they've released most recently. All you need to do is click that button, bit.ly, ANN Vector Search Raffle. I'll put that link in the chat in a minute, or you can take a photo or a screenshot of that QR code. You may know that SingleStore has had a free trial offer for a while, but just in recent, maybe the last week or so, we've also announced a fully free shared tier, which we'll talk about a little bit later today. But this raffle process is very simple. Just visit the link, sign in. You can sign up for a new account, sign into an existing account. In any case, you will be registered, and we will announce the AirPods winner at the end of today's session. Let me introduce our speaker. Akmal is a senior technical evangelist at SingleStore. He's got strong expertise in big data, machine learning, and AI. He is a prolific author and a regular speaker at our weekly webinars. Welcome, Akmal. You now have the floor.
Great. Well, thank you very much, Matt. And thank you all for joining. So wherever you are, I always check my clock and it's always 6 o'clock. It's on my time here in London. So it might be, I think, if you're on the West Coast of the US, it's early morning for you. If you're in Asia, it's going to be very late in the evening for you indeed. It may even be the next day. So as Matt mentioned, we are going to be using the shared tier, and I'll show you how to get started with that. Okay, so he'll post those couple of hyperlinks that he went through just a few moments ago, and I will show you how to get started with that. Okay, it's dead easy. There was a time when you kind of had to wait for some resources to be provisioned. With the shared tier, it's a lot easier now because essentially you just click and then immediately you get some space, you get some resources, and you're up and away. So we'll take a look at that. Excuse me. Okay, so I am going to cover a couple of things, and we'll run through a demo as well. There are lots of great blog posts that have been published on our website recently, particularly by Eric Hansen and other colleagues. They go into what I'm going to discuss today in far more detail. In fact, there's an awesome demo that Eric has shown, which combines a couple of the technologies that we have, such as full text search, for example, with ANN. And he evaluates a number of alternative ways that we support in terms of the indexing as well. So that's going to go into far more detail than I have time to do today. But we will share the links with those for those with you. And additionally, there are additional resources there as part of those blog posts as well. So, for example, how to load up millions of Wikipedia entries and then do the indexing. There's appropriate notebooks and data generators as well as part of that. So I'm going to keep things a little bit more simple today. So we'll do a little bit of an introduction, as we always do, on SingleStore. I'll mention briefly then something about ANN for vector search and some, there are a variety of index types that we support now, okay, just announced very recently, last month, in fact. And there is this new vector data type that we have. And then I'll show you a demo as well. Okay, so let me just move on a little bit. Okay, so a couple of words about SingleStore. Combines both OLAP and OLTP. A single database product can, support both of these requirements, which is pretty unique in the marketplace. I mean, not many other companies can do this. Historically, go back in time a few years, and it was an in-memory OLTP database system. Awesome performance. Subsequently, added support for analytics, columnar store, these operations, sun, min, max, average count, which we want to do at scale, and then has other features and capabilities as well. So in the next slide here, we'll go through those. So if we take this kind of 30,000 foot view with SingleStore and its kind of universal storage, okay, handling both the OLTP and the OLAP. And then we have a variety of ways that we can work with this technology in terms of ingesting. So in the past, if you've attended previous webinars, you know that I've shown Kafka quite frequently. I came from a background where I worked with Spark for quite a while. And, if you want to do some type of big data processing, machine learning, that's a great technology to work with. Additionally, you might have data in some of these other environments, such as S3 or Hadoop HDFS. And I think the animation here, which is kind of working, I'm using a slightly different browser today, but I think what this is demonstrating is the ability to kind of ingest these various data in parallel at scale into SingleStore DB. We are a cloud-based environment, okay? So we run on the three major cloud platforms, AWS, Google Cloud, Microsoft Azure. And today we will be using AWS, and I'll show you how to get started on that momentarily. Can work on-prem as well. Okay, we have customers doing that, so running in their own environments and their own cloud environments as well, private clouds too. That's a possibility. And there is a Docker container as well, okay? So, but seriously, the best way and the easiest way without any risk in terms of having to download anything and install it on your machine, for example, or in your environment is just to sign up for the free cloud-based environment. Everything is in the browser, and everything that I show you today is running in the browser. I don't have anything that I've installed locally. In fact, I've made it even simpler today in that the notebook itself is standalone. Basically, you can just click on the first cell where there is a code, and then you just you can say run all cells, and it will literally do that for you. There isn't anything else that you need to get going. It is multimodal, so yes, it has a relational background, but it does support geospatial. We've done time series in the recent past, and it comes also with the Lucene full text search engine, which is great for combining, if you're doing sort of semantic search with the vectors, that's great, but you might want to do some additional search, and full text search gives you that capability. So the ability to combine these two technologies could really give you a great advantage and could be very useful for certain applications. JSON, that's been there for some time, even better now with the SingleStore Kai, MongoDB compatibility. So if you think about it, the product is actually both MySQL wire compatible and MongoDB wire compatible. We also do vectors, and this is the focus of today, and I'll say a little bit more about that momentarily. And then finally, just to wrap things up in terms of applications, AI apps, dynamic experiences, dashboards, ad hoc queries, machine learning. And so, again, if you're a regular, you'll know that I often speak about Metabase. It's one of my favorite dashboard tools, simply because the free version is just a jar file. You just download it, and within a couple of minutes, you can actually have some nice visualizations created, pie charts, graph, bar charts, and things. And it's very, very easy to connect to a SingleStore DB. But if you work with other tools, Tableau, for example, or others, very easy to do. As long as there's JDBC, ODBC support, you can connect and get going very, very quickly. Okay. So let's move on a bit then. So the ANN for vector search, then what is vector search? Useful for RAG, semantic search, text, face matching, object photo matching, quite a varied selection of use cases. And typically we have here, I guess this is kind of trying to represent Euclidean distance. So we have some kind of query that we want to run, and we're looking for certain matches within a certain distance here, nearest neighbors, for example. And then we've specified that we are interested in the 5 nearest neighbors. Well, obviously, it's picked out these particular cases here. Okay. And you can see that a couple of them are a bit closer than others, but that's the limit that we've imposed in terms of finding the ones that are nearest to this. Some types of use cases. So we've demonstrated this in the past. So you may have come across something called FaceNet, for example, which is great for generating these vectors for images. And so here's an example where we've set up a table that is storing 2 sort of columns. One is the file name, okay, just here. And the second one is the actual vector. And now we can do it directly using this vector data type. Okay, so you'll see more about that very, very shortly. And then the vectors themselves we can generate using FaceNet here. Okay, and then we can ask these kind of interesting queries and say, well, look, here I want to find the vector from this people table where the file name happens to be, in this case, Emma Thompson. And then look for things that are similar, and then it will match those. And here it's come up in descending order. Okay, so higher values are better. So if we look at the score, for example, on the left-hand side, we can see that indeed we've got a couple of good matches here. That one is almost a perfect match in terms of one, but we've got another good one just below it as well. Okay. So something like this, closest match using vector similarity, very useful. And in the past, we've actually, there's a customer that used this capability, and it was actually very important because they were monitoring kids, and they may be vulnerable. They may be in trouble. They may be, they've had difficulties at home, for example. They're out on the street, and be able to search images, be able to find them quickly. It could be a life and death thing. Okay, so that's something that could be very, very important and very, very useful indeed. So where did these vectors come from? Well, I'm sure you've been working with large language models. This is really a thanks to OpenAI, I guess, that we've seen this area really grow significantly. But there are other technologies that have been around for a while as well, such as BERT, if you've worked with that. And then you've got other vendors as well, such as Cohere, for example. Custom models, perhaps something you've developed internally within your own organizations, okay, your data science teams, machine learning teams. Maybe you've used things like neural nets, for example. Okay, so VGG FaceNet, which I mentioned just a few moments ago. And then neural nets for image matching. Multimodal, this is kind of interesting. So recall that a couple of moments ago, I said multimodal. So we talked about time series, geospatial, so on. Here we're talking about multimodal in the sense that, with ChatGPT, I think for a long time we focused just on text and things like documents that store text. So it's a PDF documents, for example. Now we are seeing that there is significant interest and uptake in, say, maybe we want to store audio, for example, or we might want to store images as well. And then how can we query all of these in a meaningful way? So if you look at ImageBind, for example, from Facebook, which is a technology that I've just been evaluating recently, haven't got very far with it. Okay, it's on my to-do list and something that I'm looking at in my spare time. That provides a way to be able to, look at a variety of different, ways that data can be represented. We may have images, we may have sound, audio, we may have text. and it can provide a meaningful way to be able to represent that and be able to query that as well. So, for example, I might have a picture of a fox. The quick brown fox jumps over the lazy dog. That's a well-known phrase in Western culture. I may have an image of a fox jumping over a lazy dog. I may have speech, my words represented in an audio form that says exactly the same thing. So I'm referencing the same thing. And then if we could store this in a meaningful way and then have the database allow us to query that as well, to be able to get the information back in the way that we want it, perhaps we want all three ways, or maybe one of them, that would be really, really useful. A little bit about the history then of vector search in SingleStore. So 2017 is when we first introduced the support for vectors, and originally it came as blobs. So that's how it's been for a while. And we've provided support for two main operations, okay? So the dot product and the Euclidean distance. And this gives you exact nearest neighbor, okay? It's kind of no indexing there, as you can see in this particular approach. So it's great for millions, possibly tens of millions. But if you're scaling up to much larger numbers, you may struggle a little bit with this approach. It's fully integrated into SQL. Say the vector functions have been there for quite some time, originally requested, I think, by a financial customer it was. And it does very fast. I mean, for the scale, and you'll see an example of this in the notebook momentarily, we will be querying that, and it works well to a point, okay? 2022, move forward in time a little bit, ChatGPT generates surge of interest, and then everybody's become a vector database vendor now, okay? So they've added support for vectors. And so SingleStore, we haven't been sitting on our hands. We've done something about this. So we've improved the support for vectors that we have through this ANN search, okay, approximate nearest neighbor, and this new vector type, okay, which you'll see some examples of today. And then, of course, you have a choice. You have a variety of different technologies out there on the market that provide various levels of vector support, all the way from libraries that you can use for just in-memory sort of capabilities to full-blown sort of vector database systems. But why use SingleStore for this? Well, it's technology that's been around for quite some time. We are a distributed SQL database, the ability to scale out. We support SQL. SQL is still one of the most demanded skills in the world in the IT space, along with Python, I think, these two. It's fully transactional. Can do analytics at scale. We talked about the OLAP capabilities. We can combine both vector and full text search as well. And the thing is that it's one product that supports all of these. So from a technology perspective, if you are a developer, you do not need to learn half a dozen different products in order to be able to get some task done. SingleStore supports all of these capabilities. From a business perspective, it's great because as a business person, your TCO, your return on investment is much better. Again, there's no need to pay license fees for half a dozen different products and be able to combine them. Now you have one product that can support all of these capabilities. So there's kind of benefits in both of these directions. Okay, a little bit more about ANN indexes and search then. So we support a number of these ANN indexes, okay? Now, unfortunately, because of lack of time, and Matt will tell you this, I have a habit of talking too much and going on for too long, and we need to leave time for questions. So we will provide appropriate references for this, but the documentation cover this in a great sort of detail, and Eric's blog posts also discuss this far more detail than we have time for today, okay? So there's a wide range of these that we support. And this is useful in terms of where the amount of data that you want to query becomes very large. You need fast response. Maybe you're in an environment where you're getting a lot of demands in terms of the system, lots of people sort of running queries on there. But you don't need perfect recall in the sense that what you're giving up is accuracy for speed. But the thing is, the accuracy can be, it's one of these kind of trade-offs. In the example that I will show you, you'll see that it's not, the accuracy is okay. It's acceptable in terms of the responses I get back versus having to do the full KNN And then, yes, I may get a perfect answer. The world that we live in today is highly competitive. People want answers fast. Business decisions have to be taken much faster. You know, it's time is money. And there may be situations where it's sufficient that you may not get a perfect answer back, but you get the answer back very, very fast. And that's exactly what you may need. And it's for those kind of environments and those kind of situations where something like this, approximate nearest neighbor, hence the name approximate, is enough for your needs. Okay, so getting answers back quickly versus having absolutely 100% accurate results. As I mentioned before, we support the dot product and the Euclidean distance directly. Cosine similarity is easy to simulate. You can use the square root function in SQL as with the dot product to achieve the same thing. Although, you know, like I said, we don't have a specific cosine similarity function, but it's very easy to be able to represent that within the product. And so there are many different ways in terms of distant metrics. I'm sure if you've worked in this space, you will come across many of these yourselves. So each k nearest neighbor or approximate nearest neighbor algorithm only works for certain distant metrics. There can be some situations, for example, where some of these may not scale up as well as others. Okay, it's one of these things that you, again, have to choose the one that is best for the job. This thing here, product quantization, you will come across this as well. Again, indexing doesn't come for free, right? There are resources required. It does take up space, but there is something that you can do about that. And this is particularly applicable to this particular sort of problem, if you like. So this technology, this approach, you lose something in terms of fidelity. But what you gain is lots of savings in terms of memory, okay, and enormous improvements in terms of performance as well. So I think what it's trying to show you here, you know, think of this as like a JPEG for vectors. So it's a lossy vector compression, but, you know, has many, many benefits to it. And then we are able to support this as well. Okay, let's go on a little bit. Sorry. Right, now I've skipped over a couple of slides in between because, like I said, I am conscious of time. There's stuff that I want to show you. But two of the ways that we support this kind of inverted file index and this, you know, it's a navigable small world, if I can say it properly, hierarchical navigable small world. There are trade-offs, okay? So again, it's a question of choosing and picking the right technology for the job at hand. The documentation, the blog posts cover this in far more detail than we have time to do today. Be careful not to index everything everywhere. I've seen that in my lifetime in some of the projects that I've worked on in the past. You know, indexes, as I said before, don't come for free, right? There are overheads attached to them, but they can be tremendous accelerators and very, very useful for certain problems. Okay, so treat them with caution, use them carefully and sparingly, and you will gain great benefits from them as well. All right, quickly then, data types. So essentially, as I mentioned before, you know, way back in 2017, we started with this kind of blob type, which is how it's been for a while. And now we've added this specific vector type. Okay, so you can specify the number of dimensions that you want. So in this particular example, it's 1536. And currently, you know, if you wish, I mean, you can add this. It's 32-bit floating point. I assume that's going to be possible, perhaps additional support in the future as well, just like we have with the other types in SingleStore. And the key benefits that why we've gone down this road, well, it's more readable, self-documenting. It does some compile time error checking for you as well as this kind of length type mismatch as well. So if you try to put in something that's smaller than this, for example, or bigger than this, then it will give you an error. And you need to go back and fix that, okay? So that's much better. Previously, with the blob type, we had, in order to get the data into the blob column, we had to use this JSON array pack and JSON array unpack in order to get the data in and get the data out. Okay, as kind of mentioned just down below here. And again, if you've attended some of our previous webinars, you will have seen us use that capability. Now that kind of goes away, right? That's much easier to work with. We've also introduced some infix operators. So rather than having to type dot product or dot underscore product or Euclidean underscore distance, now we've got these infix operators. So this one is an example of the dot product, much easier to use. And then automatic casting as well. So if we take a look at this example here where we've created a table and we've specified the number of dimensions here for this vector, which is 4, we can simply insert it straight away like this. As you can see, this is a lot easier, much more readable, versus having to go around the other approach where we use the JSON array pack, JSON array unpack, which essentially, I mean, you can look at the values, but it's not human readable. I mean, it's just a bunch of sort of binary, if you like. Okay, and we have provided means for existing customers to be able to run these kind of casts. So if you've been working with blobs before, there are ways and means that now you can take advantage of this new vector type as well. Okay, so that's much providing a sort of transition to the new approach if you want to do so. Okay, so here we've got the two operators that we've support. If you've worked with Postgres, you will see where these come from. Okay, so the one that's missing here is the cosine similarity, which I think is supported in their Postgres approach. But as I mentioned before, we don't have a direct function for that, but we can simulate that and represent that as well. Okay, so let me stop there now and try and switch to this in the first instance. Let me blow this up. Okay, see if we can get that. There we go. So if you followed the link that Matt has posted in terms of the AirPods draw, you will click on that and it will get you like a sign-up page, and just either use Microsoft or Google or just put your email address and create a password. Literally, I mean, less than a minute of your time, even 30 seconds would be sufficient to do that. And once you've done that and it's verified and you log in, essentially you'll see something like this. It may be a little bit different for yourselves. I'm actually using an account that I normally don't use, but that's fine because I want to show you a couple of things as well. So on the left-hand side, you'll see that you've got a couple of these capabilities. Let's have a look. There's a SQL editor, and we've got notebooks down here. Okay. And so the main thing here is if you take a look at this thing over here, cloud. Okay. And you can see it's got this kind of group. Okay. So if I click on this, here is where you can create this starter workspace. You can create a standard one as well, if you like. Just option is there, right? The starter one is free. Standard one, I think it's $600 of credits, but this is super simple to get going. Workspace name here, it's kind of pre-filled. I'll take the default there. And as you can see, your choice of cloud provider is AWS, and the region is currently US East 1 there, North Virginia. And I just need to go down here and say, create starter workspace. So if I do this, it's done. You literally, I mean, previously, if you provision the standard, you have to wait a little while, okay? Because it's churning away, chunking away, creating the stuff for you, but you're ready to rock and roll. There you go. So there's your compute environment, and you get a default database as well, okay? So you can, I think the limit is it create up to 10 tables, but that is, I mean, you can choose the database name if you want. You could do that in the previous step, right? But that's fine. I'll take the default. No problems there, right? We've got some details about this specifically, but this is the free tier, okay? Great to get started, very fast, as you can see. Straight away, you can start running stuff. I've got a notebook here that I've set up on, there we go. Kernel's been sitting idle for too long for a while. And so this is something that I was working on. So as I said before, this is very, very straightforward, extremely simple. Literally, I could just position my cursor in the first code cell here, and I could go to the top, and I could just say, run all cells, and it will just run through and complete all of these. And we'll share this with you a little bit later on, okay? So the one kind of catch and a little bit of warning that I alluded to earlier is that further down here, let me just show you this before we go through this code, okay? And just as a kind of word of warning, it's good to be reminded, is that I do a bit of this dimensionality reduction, essentially taking 784 dimensions, reducing it to 2, because I want to render it as an image. And this image takes about 10 minutes to render. So that is what I wanted to just, there's a word of warning here as well that I put in. Okay, so let's just go through this. Okay, so what we're doing is we're going to use TensorFlow, and we're going to use Matplotlib, okay, like so. And we'll just do a little bit of a setup here. Okay, just do some imports. We are going to load this data set, which is the fashion MNIST, okay, from Zalando. It's a few years old now, but still very, very useful. And if we take a look at what it gives us train data, 60,000 images, grayscale, 28 pixels by 28 pixels. Test images, 10,000, same 28 pixels by 28 pixels. And obviously you get the training labels and the test labels as part of that as well. And if we take a look at one of these images, here it doesn't look very nice because it's just kind of wrapped around. Okay, but if I take a look at the label for this, the label for this is the value 9. And if I take a look a little bit further down, this actually maps to this ankle boot. Okay, so you've got t-shirt, top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, and ankle boot. And then what we can do is just take that and simply plot it. There we go. I mean, that's what it looks like. That's what the rendering is. And we can actually take and have a look at the first 10, if you like, as well in our training data set. And this is what it looks like across 2 rows there, just to see what these images actually look like. So our first task then is to say, well, okay, this is kind of 2-dimensional, right? 28 by 28. Let's just flatten this then. And this is what we do down here. Okay, so we just do the reshape for both the train and the test images. And then what that gives us is, again, the numbers remain the same, but you can see now it's 784 dimensions. So do the math, 28 by 28, and that's what we've reduced it now down to. The next step here is just to prepare those NumPy arrays and create a couple of data frames here. Okay, one for the training data, one for the test data, and then give these columns a bit of labeling here. You can see I've decided to choose IDX, image, and label. Okay. And then we take a look at the first 5 rows. So what we've got is our kind of unique identifier. Here is that vector represented in the image IMG column. And then we've actually stored the correct text label along with that as well to tell us what it is. In this case, ankle boot. Okay, and I've done the same here just below for the test data. It's identical, okay, in terms of I mean, just coincidentally, it happens to be ankle boot there as well. But what it's done here, you can see it's kind of chopped off the image there, but that's fine. Oops, pardon me. I'm not sure what happened there. Sorry about that. Just there we go. Okay. So in order to store this into SingleStore, you saw in the slides the example that I showed you that literally as a string, we can store it. And all I'm doing here then is just converting those 2 data frames using this apply string, convert them to a string format. And so again, take a look at the data frame, add this extra column called vector. And here is sort of the value again. You can see that now that is a kind of a textual representation of that NumPy array. And do the same for the test data, okay, just below here. And then finally, we can get rid of the image column. We don't need it anymore. Okay, so we drop that, and we drop that in both of these data frames. And that's all we need to do. The next step is just simply to connect to the database. And this is using this kind of built-in capability that we have, this connection underscore URL, which picks this up from up here. Okay. So this is why this free tier is so useful, because by default, you have like the workspace and a database created for you. If, however, I mean, you've got other things in this in your environment set up as well, I mean, make sure you select the right one. Okay, so in this environment, you can see that other people are. I'm playing well. I'm sharing this environment with other colleagues as well. But it just so happens that this is the one that I'm using. So we just drop the tables. Okay, it's a slight messing up of the text there. I'm not sure why that's done that there, but that's okay with it. It's the code itself is fine. And then we just create the two tables here, one for storing our training data, one for storing the test data. And we are using this new vector type here. Okay, 784 dimensions, 784 dimensions, and adding this not null to the end as well. Okay, just for safety. I think if you don't have that, it will give you an error. For small cases, that seems to be fine. But in this particular case, I think it will insist that it's there. There, we just take the data frames, we write them into SingleStore straight away from this environment, okay, just using this 2SQL, okay. So our data are now stored in the two tables. And then just as a sanity check, what we can do is just read a little bit of data back, just to confirm that actually it's gone in correctly. And so here, we just do a select star from train data vector limit 1, just pull one back, and just convert that back to a NumPy array, and then visualize it here just below. So in this particular case, what we got back was a pullover. So that's fine. I'm happy with the fact that everything seems to be have gone incorrect. The next task then is just create an index on that, and this is the new again capability. So you saw me using the vector type just above. So this is the other part of the new stuff that we brought out just last month, the announcements that were made. And here we just use this alter table command to say, okay, add this vector index. And what I'm going to do is index type auto, okay? And it's going to be on Euclidean distance, okay? You can choose dot product as well. That's possible too. Those are the two metric types that are currently supported. That index creation is just on the training data, okay? And here you can see that it took about 3 seconds. So you see from the timestamp there, I did that a little bit earlier today. All right, now let's run a couple of queries then. So in this first one, what I'm going to do is I am going to look up a value where the index IDX column is equal to 30,000. Okay, so that's roughly halfway through the data set. And I am going to compare that with all of the other values within that table to find what else is similar to that. And so the result below, you can see, well, obviously the value of 0, it's itself, right? That's the first value. That is the best match that he's been able to come up with. That's fine. And then we've got other here, 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 and here, okay? And then these, we can kind of, again, through a sanity check, you can see the label, they all happen to be dress, which sounds about right. And then in this first one, I've actually not used an index. So the key thing here, what I've done is I've done an order by, but I've specified, yes, this index, but notice that I've used this kind of parentheses and it's empty. I'm specifically telling the database system, do not use an index in order to retrieve the results for this. And so for this, if I take a look at the time, it's about 277 milliseconds. Now, I spent 6 years doing benchmarks. So the thing is, you'd run this a few times, okay? I mean, you can warm up the cache, you warm up the indexes, there's all sorts of things in terms of how you run and where it's actually storing the data as well. But this is a first initial pass through, and that's kind of the numbers that we've got. Quickly then, in terms of the next query then, so again, we are not using the index, but we're saying, all right, take something that you haven't seen before. Look at something from the test data table, take a value from that, where its value is equal to 500, and then find me things that match that in the training table. And again, it's done that. And you can see here that it's done a pretty good job. Okay, so now we've got pullover for all of these. Okay. And it's given me the score. And again, if we take a look at the time, that's sort of 258 milliseconds to run that. Just below then, we take advantage of the index for both of these. So we do exactly the identical queries. This time, though, we are utilizing the index. So that little statement that I had earlier saying don't use the index, I've taken that out now. But other than that, the query is identical. And so again, we can see in this particular case, it's done a pretty good job. It's matched the sort of KNN approach that we just did above. Okay, all of these, address. But look at the time for that, 79 milliseconds to run that. Okay, much faster. And then similarly here for the test data, where we said again, take something that you haven't seen before. It happens to come from a different table. Use that as a means to compare against what you have in the training table. And it's done that. And again, you can see that we get pretty good results there as well. 115 milliseconds, again, much faster than the previous approach. Notice, however, though, in this particular case, because it is an ANN index, approximate nearest neighbor, we find that in terms of the results, yep, we get pullover and pullover and pullover and pullover, but one of these is a shirt, okay? So it isn't as accurate as the previous result that we had earlier, but for my purposes, it may be sufficient, and that might be okay. The fact that it runs a lot faster could be very important to me. I get my results back, but I lose a little bit in terms of the guarantees that it's going to be absolutely perfect answer. So, and then just below here, just to take a look to see, well, why are we getting these kind of numbers? Well, if we just take a plot and do this kind of dimensionality reduction, we can see here that if we take a look at these different items of clothing, there are indeed a lot of similarities between them. So looking on this side, for example, we can see that a whole bunch of this kind of footwear is all very close together. Ankle boot, sneaker, sandal. Okay, and similarly on the other side as well, we've got dress and shirt. Okay, looking at this image, it reminds me very much of let's have a look. It's almost like a hand clasping a face. All right, there we go. And this could be someone's head. And there's their chin. But you can see the idea, okay? So even doing something like this, the fact that these are grayscale images, there isn't going to be a perfect match every time. Even plotting it like this, we can see that, yeah, chances are things that sometimes look similar, they are from the same sort of general category, then we might find that, yes, they are actually going to affect the results that we get. And then just below here, what I've done is actually done a bit more here in terms of building a model. This is using TensorFlow, okay, and it's gone through a number of iterations to have a look and created this kind of heat map. So we see that often things like shirts and T-shirts, for example, have a strong overlap, okay? The accuracy of the model is affected by that. Pullovers and shirts, again, okay? And coats and shirts as well, okay? These things images kind of tend to look very similar, and that's affected the overall accuracy here. Okay, so quickly then, let's just check the time. Great, I'm going to finish early today, which I think will keep Matt happy. But I did mention two blog posts, and we will send the links out to you. Okay, so this one was published on January 19th, Vector Data Type Support in SingleStore. So Eric there and Vyacheslav, forgive me for butchering your name, did an awesome discussion of the vector data type. And then here we've got something that goes into far more detail. So this is actually using Wikipedia and then evaluating a lot of these index types, okay, that we alluded to, we mentioned briefly in the slide deck. Again, because of lack of time, we're not able to cover them in detail, but they actually check these out against each other just to see the kind of performance that they would result in. And there you can see this is from Eric, Rohit, Cheng, and Nadeem. So let me just go back here and just to summarize then, okay. And then we'll just hand it over to Matt. So why use SingleStore? Full power of SQL, transactions, parallels, and scale out. These have been in the product since day one, almost, I would say. New vectors queryable as soon as transactions commit. That's something that is very useful. So as soon as the data has gone in, it's committed, it's available immediately for querying and asking questions of the system. Powerful hybrid search in one DB engine because we can do the vectors, we can do the full text, you can run SQL queries as well. If you've got metadata, you can store that as well. All of this in one environment and one engine essentially to power all of these different requirements. You're wondering benchmarks. We often get asked this question, how fast are we compared to, say, these specialty vector databases? I believe Eric has mentioned this in his second blog post that benchmarks will be published very soon. I think there's a blog post that's going to come out as part of that. So, please watch this space. Currently, much faster than PG Vector, Rockset, other similar technologies. So it's worth considering this. Have a look at the documentation. This simple example, you can run this in your own time. Aside from the rendering that for the TSNE, which, like I said, does take about 10 minutes, everything else is super fast. You can comment that piece of code out if you don't really want to run that. And then you can try it out with some of your own values, for example, or scale it out a little bit more. But this is a kind of reasonable data set in the sense that, it is giving us the opportunity to push things beyond just, say, a couple of dimensions, 784 dimensions. Plus, we are able to create an ANN index on that. And you saw me just doing some crude performance tests there. And we saw that, yep, we are not getting back a perfect answer in one case, but I may be perfectly happy with that. Okay, so that's the sacrifice. It's immense speed, but may lose a little bit of accuracy there. And with that, I am done. And I think you're happy today, Matt, because I finished early. So there we go.
Yeah, we've got plenty of time for the Q&A. So audience, I know we've already got some coming in, but feel free to click that Q&A button at the bottom of your console. We've got time to knock some of these out. We'll try to get to as many as we can. Akmal, the first that I'm going to give you is, do you have some sort of metric that you can use in order to tune the approximateness of ANN?
Oh, that's a great question. Off the top of my head, I don't know, but we can follow up with that. Thank you for asking that. That's a really good question, and I can understand why that would be very important. In production environments, that is something that you would want to check. All I would say is that if you want, you saw in the example, there's a kind of you've got two choices: either use K nearest neighbor or use ANN. K nearest neighbor, you're guaranteed. Okay, you're going to get the correct answer. There's no opportunity. There's no index there in the case of SingleStore, for example. With the ANN, you're getting the fast result back, and you have the choice of various indexes. There's things that you can specify in terms of how you set up the index. You saw me just using two parameters today. The choice of the index, I chose auto. and the distance, the metric, if you like, which was Euclidean distance. I mean, you can specify dot product as well, but there are other things as part of that index creation process you can specify. There are defaults as well that it has, and you can tune those specific parameters as well. In terms of guidance, figuring out what is best in certain situations, that would be awesome if we could put together something like that. And let's look into that, Matt. So thanks for that question, whoever asked it, and we'll follow up with that. I mean, that is a very important point, I think.
Cool. You've got a couple questions about the image that you produced. So the first one I'll give you here is from Kira. Why would you want to produce this image? Does this make the data easier to analyze because you can see the clusters?
Was this the one for the TSNE? Was that the colorful kind of rainbows and?
I think that's when it came in. Yeah.
Okay. Yes. So I was very interested to get an understanding of what does this look like. Now, obviously, trying to render 784 dimensions is rather hard. Okay. We are used to kind of 2 dimensions, 3 dimensions at most in terms of visualization. So TSNE is just a way of kind of dimensionality reduction. I was just curious to see, was there any kind of relationship between these items of clothing? And you can see something in the visualization straight away that, yes, you can see that, footwear, there is there's a similarity there. And then if you're kind of asking queries of that, let's say you're looking for an ankle boot, chances are you might get a sneaker back as a result, or a sandal or something. Or if you're interested in a t-shirt, you might get a shirt back. So it's just kind of getting a handle on the data and knowing that, yes, there's 10 different types, but some of them are somewhat more similar to each other than others. And that may affect the results in terms of when you're asking queries. So it's just an extra bonus thing for this particular use case. You don't need it, but I was just curious to see, what does the data actually look like? If I visualize it, how does it appear? That was the reason for doing it.
Good stuff. Thanks, Akmal. A couple more questions, but one I'm going to chime in on. There's been a couple questions about the free tier. Some people say, I've started up my free tier, and other people say I can't see it. So basically, I think this might have something to do with the status of your trial. If you can't see it, feel free to go to our website, singlestore.com, click the banner at the top, and just create a new account. You'll see at the top when you start that, there's something called starter free. That is the free tier as you're doing the deployment settings. So feel free to do that if you don't see it, and you might already have a free trial or something. If that's the case, if you can't see it, just basically start over. I see one here from Christopher. Akmal says, thank you, Akmal. This is great. Are there any mechanisms or controls we have access to for tuning the ANN algorithm to handle that trade-off between recall versus latency with a simple swapping between the algorithms? I'm hinting a bit here about something that's similar to the type of control you can get with Google's Scan.
Right. Okay. I'm not familiar with that Google technology, but I suppose I should go away and educate myself. Matt, I'll do that immediately after we finish. So thanks for that, Christopher. So yes, again, great question. So this kind of touches on, I think, what was asked a little bit earlier, the earlier question, Matt. I would love to see technology, and then maybe this is some kind of tooling that we could build into the product as well to help guide the database developer, if you like, designer, to understand the trade-offs between these different sort of indexes, what's possible, the parameters. Like I said, there are defaults that come built in. Those defaults may not always be the best. How you can spend an enormous amount of time tuning and figuring out what's the best approach. It would be great to have more automation built in and guidance, and essentially like a sort of wizard, if you like, that questions you and then looks at that and then builds that for you. I used auto specifically today, but auto is kind of restricted to one approach right now. In the future, I would like to see, this is just my personal request, I mean, nothing to do with SingleStore, but what I'd like to see is more of those options available under auto, and literally auto handles that for you. So it can analyze the patterns and then perhaps over time be able to change and re-index. But indexing, like I said before, I mean, it doesn't come for free. There's always a cost associated with it. And especially if you've got a very large index, trying to drop that and reconstruct it again could have sort of, tremendous sort of time and cost associated with it. Again, great question. And I'd love to see more. The documentation that we have will help to some degree, but I think our technical resources would probably the best. Those who work in the field with customers, they would know a lot more. So we can put you in touch with somebody that would know a lot more than I do.
I
That
can add.
sounds. Go ahead, Abhi.
Thank you. Akmal, in fact, what you mentioned, what's on your wish list is already on our product roadmap. So auto indexing will come for our ANN algorithms. So it'll be much easier for people to select what algorithms would work for them. There's also other very cool features coming up. There's going to be, we'll allow GPUs to be able to build indexes, vector indexes. So those are just some of the things that we're very excited about that are coming.
Awesome. And whilst you mentioned that, Abby, I can just go back here a sec and actually, where was it? There we go. I'm privileged to have access to something that you guys don't, and that is GPU. Okay, so there you go. So there is an internal preview. Okay, so I actually selected a GPU here, which is something I've been playing around with and using. So that, as Abby was saying, we've got stuff in the pipeline and lots of cool things, toys for boys, as they say, or girls. I think that's the phrase from Eric. But yeah, there's great stuff coming along, and it's great to know that this auto capability is going to have a lot more support as well, Abby. That would be great. We do provide a lot of insights, and the optimizer can show you the query plan and how it's going to evaluate the queries in a visual way. That's awesome. And having this capability extended to the indexing for this ANN, I think would be just great.
Awesome. Thanks, Akmal. Maybe one or two questions before we announce the AirPods winner. There's been multiple questions about like industries or use cases. One is from Suyash asking about, are there use cases here for retail that SingleStore has helped on? I see another one from Ram that says, what about image captioning mechanisms involved in healthcare or automobiles? What do you think, Akmal?
Oh, absolutely. You guys haven't been attending our webinars. Clearly, I mean, you've missed the last couple of weeks. Ayush from one of our external presenters has been doing stuff like insurance documents, claims, and visualization. So looking at accidents, for example, and then putting in the insurance claims for those. So yes, we've got a wide range of verticals that we work across and horizontals, and we've got customers in many different sort of spaces. So keep in mind that the vectors, what is it? It is just a numerical representation of some data. In this particular case today, for example, you saw that I didn't have to do much in terms of generating it. Essentially, the values come as part of the data set. All I did was simply squash it down into a long value. And then that is something that can query straight away. If it's an embedding for, say, from an LLM, again, we can store that. We can query that. FaceNet for images, we've got examples of that. We have companies in the insurance domain. There's an example that I've mentioned previously as well, that we had a customer who was interested in storing PDF documents, for example, and these could include images and tables and all sorts of other things as well. Currently, they use OCR to do that, but using our technology, for example, and utilizing some of the aspects of LangChain, for example, great framework, they have now simplified that process or are in the process of doing that. It's a big task for them, but they're going through that process of utilizing that now, storing the embeddings, querying it, and they're finding that the accuracy level has improved significantly for them. It's a much easier task for them as well in terms of getting the data in and getting the answers out. So yes, you guys, please reach out to us, okay? And we can follow up with you and give you specific customer examples. There's lots of case studies, verticals and horizontals that we work with. We'll be happy to do that.
Good stuff. I see that we're in the final minute. So as I said in the intro, we're going to get to any unanswered questions. We will follow up with you via email. So thanks for getting those in and feel free to keep them coming. Quick note before I announce the AirPods winner, reminder that Wednesday, 2 days from now, we're going to present inventory management using AI, using object and image detection. Speaking of other industries and use cases. So come join us on Wednesday to learn how businesses are using AI to manage inventory more effectively and also reduce their costs. I put the bit.ly link for that in the chat. Hopefully you register for that, and we will see you on Wednesday. Today's AirPods winner goes to Kaushik Dixit at Whirlpool Corporation. Very cool. I'm curious to see how you all are implementing this kind of technology. Congrats. Thank you for joining us. If that wasn't you, don't fret. We're going to give out one more AirPods later today to one lucky winner who has tried out Akmal's notebook. So the notebook showcase today, keep an eye on your inbox. We're going to be emailing that out along with the recording of this session so that you can follow along and play around with that notebook yourself. Thank you so much for joining us. Thanks to Akmal for another awesome presentation and demo. Thank you to our audience for sticking with us. Bye, everyone.